Good morning, students. On behalf of Alpha Group of Institutions, I welcome you all for this digital journey. Today, we are going to start with the chapter 1 Computer Networking. So, in this chapter, we are going to learn about what is networking and what are all the advantages of networking, the components of a network, and what are all the types of networks available, and the different types of topologies and the protocols, the predefined standards, and the last one is the architectures of network. What are all the architectures used in the networks? First, we will start with what is networking. So, before learning about the term networking, we must know what is a network. So, network in simple word, in a simple term, we can say it as a connectivity among the users. So, networks can be found everywhere. Even for example, we can make telephone calls in India or anywhere else in the world with the help of the telephone or the mobile connection. So the connectivity, the term connectivity refers to the network. So this network consists of interconnected telephone cables or the microwave links. The waves that connects the with the help of the link, we call it as a microwave link. Similarly, we can travel to any destination within the city or to any other city in India or outside the country, as these places are connected by a network of roads, railway lines, and airlines. So, that is the common example. Here, computers in different places can also be linked to create a network of computers for sharing the data or exchanging the information among the computers. So, here the computers are connected in the network. So, most of the organization today use computer network because most of the organizations are located in various places, various locations in different regions, different zones. So they use computer networks for sending and receiving the data and information. So data and information can be such as files, even it may be emails or reports or memos, whatever may be, to the company employees and their group of companies. A computer network can be spread across even a building, a campus, even a city or a country, or even across the continents. The computer network, wherever the computers are available and that are connected in the network, can easily be shared the resources, the data, so that it provides a powerful communication link among the users in different location. Nowadays, millions of computer networks join to form the internet. So when you want to know any information on the internet, the computer which we use connects with many computers across the globe to fetch the required information. For example, when you book a train ticket online, so your computer links and interacts over the internet with the computer of the ticket reservation system to help to book the ticket for the journey. So this is the general example for the computer network. And next one is the advantages of computer networking. So major developments in the area of communication and technology have enabled computer networking. So most of the communication and technology system uses this computer networking. So there are many advantages for this computer networking. So first one is it allows sharing of resources. The resources may be programs, data, or devices. Devices here, it may share the printer, it may share the fax machine, whatever may be the devices which has the Wi-Fi facility can be easily shared. And next one is the it helps in saving time and effort, as people with access to the network can share their files easily. The files can be shared easily with the help of this network so that the time gets saved and also the effort gets saved. And the third one is a network allows to have multiple copies of the important data at various locations. So in case of any data loss occurs, we can easily recover the data. So because of the network connectivity, the data are stored in multiple locations. So this safeguards important information against any computer breakdowns or natural calamities, whatever may occur, the data can easily be recovered. And the last one is networking, especially with the full across to the web, has ensured quick communication. So communication made very quickly, and computer networking facilitates cheap and easy mode of intra-office communication. Today, email is the most preferred way of fast and efficient means of communication over a network. Instant messaging allows the user to talk in real time and send files to other people within a fraction of second. So this makes the quick communication. So these are all the advantages of the computer networking. Next is the components of a network. So a computer network is mainly comprises of the hardware elements and the special software. So these two get connected and forms a network. So first we will see about the hardware. So first one is nodes. A node refers to any system or a device that connects to the network. So a node is a system or a device which is connected in the network. So a network that connects a file server, say for example 10 computers and 3 printers, and totally it has 14 nodes. So a file server and 10 computers and 3 printers. So totally there are 14 devices gets connected in the network. So that we call it as a node. So a node could be connected to the network with the help of the cable or infrared or with the help of the radio waves. And each device on any network has a network address. So that address will be unique to that device, will be specific to that device. So that address will not be used to any other devices. A device will have a unique address, and this address helps to track the where the data is transferred to or coming from on the network. So this address helps for the tracking of the data. And next one is a workstation. So a computer attached to a network is called as a workstation. So a workstation is for a single user but has advanced graphics capabilities, that is capacities, and even large storage capacity and a powerful CPU. This workstation comprises of the high quality graphics capacity, and even it has the large storage capacity and very powerful central processing unit for processing the various connected computers in the network. Therefore, this workstation is more capable than the personal computer. So workstation is much better in process than the personal computer. And next one is a server. So server, it means a computer that shares the data or the software and even the hardware resources on a network is called a server. So in a common computer, all the data and software and the hardware devices are stored in a common computer. From that computer, the resources are shared to various computers. So that common computer we call it as a server. It manages the sharing of resources among the various systems or various nodes. And the systems or the nodes will send a request to the server, and based on the request, the server will share the data or resources. So the server processes and sends a response. Say for example, real time example, in a school library, the librarian plays the role of the server. So students similar to the workstations. So the students will request the librarian for a book or a extension of a return date. Say for example, the student is requesting for a book in a library. The librarian processes the request and gives the book to the student. Say in other example, the student wants to extend the return date. So the librarian will check the system and will give the extension for the return date to the students. And next one is connecting devices. So for all these, the nodes, workstation, server, all these are to be connected, must be connected with the help of any devices. So that device we call it as a connecting device. So connecting between the computers on a network is set up using some special cables. Like it might be there are various types of cables available. Based on the speed of the data transfer, the cable may differ. So the twisted pair cable or coaxial cable and the fiber optic cable will have the fastest speed. Sometimes special devices like even microwave with that is wireless connectivity, microwave and even satellites are used. And last one is next one is a network interface cards, NIC. And the communication between the two nodes is established with the help of the some communication processors. That processor we call it as a network interface card. So already we know that interface, it fills the gap, it fills the gap between the two nodes, two systems. So that is the network interface card. And next one is shared resources. So what are all the resources that can be shared comes under the shared resources. Resources may be a device or a data or a information, whatever may be. Say for example, printers, scanners, cameras, secondary storage media like a external hard disk and other devices that can be connected to a network so that they can be shared. So this sharing can be done both wired and wireless. So this is all about the hardware, the components of a network. Under that, this is all about the hardware. And next one is a software. The next component of a network is a software. So under software, the first one is network operating system, NOS. So network operating system is a specialized operating system. Operating system is nothing but a system software. It is also a software which is a system software and which manages and it helps to coordinate the different hardware components of a network. So we already told that a hardware can't work individually. It is fully dependent on the software. So here the network operating system, the system software helps the different hardware components of a network to work. So its application and related software is stored in the workstations and also on the servers. So it also helps in sharing of resources for access and transfer of data. So this NOS helps in sharing of resources, the devices for accessing and also for transferring of the data and information. And next one is specialized networking software. So specialized networking software is required to manage, to direct and control the operations of a network. Three main things done in this specialized networking software, that is SNS. So it manages the operations of a network and also it directs the operations of a network and also it controls the operations of a network. So the three major tasks is done by the SNS. Its application and the related software is stored in the workstation and on the servers. So both the NOS and SNS and the application and the related softwares, all the related softwares are stored in the workstation and also on the servers. Next one is a network types, that is types of network. So first let us consider an example. So imagine 10 computers that are interconnected in an office. So that comes under the network. And 100 computers of an organization spread over the country that are interconnected. So that also comes under the network. Even thousands of varieties of computers all over the world that are interconnected, that also comes under the network. So all these scenarios, three various scenarios, comes under the network. So the devices may be personal computers, mobile devices, mini computers or mainframe computers. Whatever may be the devices that are interconnected comes under the network. So thus networks can vary widely in their size, complexity and the geographical connectivity. So a popular way, a common way to divide the network is based on the geographical connectivity, that we call it as a geographical spread. So on the basis of the geographical connectivity, that is the geographical spread, we classify the network types into two: the local area network, that is LAN, and the wide area network, that is WAN. So first we will see about the local area networks. So local area networks are computer networks that are connected to a local area, such as within a small radius, that is such as an office or a complex or a factory. Within a small radius, all the computers or the devices are connected. So they connect computers and allows for exchanging of the data within them. So the term localized, the local could mean it may be a room or a building or a campus for a minimum specific area. A local area network is a network that is personal to an organization. So the network that are connected in the local area network is interconnected within the organization. So local area network do not just form a network of computers, they in fact form a network of people within the organization, within the group, and they facilitate and provide sharing of information and resources among them. So resources may be a device also. So in a complex LAN configuration, one computer is designated as a file server. The one computer is assigned as a server. We already came across the term server. So one computer is assigned as a server. It stores all the software that control the network, and the software that can be shared to the required computer. Whenever the request is raised to the server, based on the request, the software will be shared to the computer. So computers connected to the file server are called as workstations. So the workstations can be less powerful than the file server, because the file server will have all the data, all the files in common, whereas the workstation will have less files based on the request. And the workstation, they may have some additional software on their hard disk. And LANs, the local area networks, that connect to each other based on their either cable or radio waves or infrared. And the second type of network is wide area network, that is WAN. This wide area network combines multiple LANs that are separated in various locations, in different locations. So it connects those LANs into a single network. So this wide area network forms a new network across a city, a country, several countries or even continents. It creates a new network across a, even within a city or within a country, or even two different countries, or even in two different continents, it creates a new network. And this wide area network forms a group of computers, linked computers that are separated by large distance. And the implementation of the wide area network is more complex because the distance is large. And the wide majority of wide area network use satellites as a primary transmission media, because for larger distance the cables cannot be, or the radio waves or the infrared cannot be used. So they use satellites as a primary transmission media for transferring the resources. Normally governments or groups of organization install wide area networks for exchanging the information. Single organization usually do not have the need or resources to install the networks on a large scale, because they won't be having that much of finance, that much of fund to install the wide area network facility. Organization having a large installation base of computers spread across the world, by connecting their computers to facilitate to communicate with the fast and efficient exchange of information with the help of the wide area network. For example, if a school computer get connected to school that is located in New York, so it will be classified as a wide area network. The internet is an best example for the wide area network, because the internet is a network of network. So internet can be termed or defined as a network of network. So that is, it is a system of networks that are linked worldwide, and it provides a large number of data communication services like remote login or file transfer or email. The World Wide Web is mainly used. So the World Wide Web, the internet, is the best example for the wide area network. The next one is important characteristics of a network. So there are three important characteristics of a network. They are, first one is topology. Topology is nothing but it shows how the computers are connected, a diagrammatic representation like how the computers are connected. And next one is protocol. Protocol is nothing but a set of instructions which gives how the computers are to be connected. And the architecture, so the overview of the connection that are established in a network. So these are the three main characteristics of a network. So first one is topology. So as already said, the way of computers that are connected on a network is known as topology. So how the computers are connected in a network is defined by a topology. So the physical topology of a network refers to the configuration of cables. So what are all the cables to be used? So how long the cable must be needed? So all these physical details of the connectivity are represented in the physical topology. The physical topology of a network refers to the configuration of cables and the configuration of the computers, and if any additional devices needed. So all these details are mentioned in the physical topology. Next one is a logical topology, focuses on the pattern of data. So how the data to be transferred. So how the data is to be combined. So the combination of data are mentioned in the logical topology. And the four popular topologies are star topology, bus topology, tree topology, and the mesh topology. So all these differs only based on the arrangement of the connectivity. So the main difference among these four topologies are the arrangements in the connectivity. So first one is star topology. So in star topology, the various nodes, here nodes means the computers. the various nodes like workstation, servers, printer, whatever may be, and the like on the network are connected to a centralized connecting device. So the all these devices are connected in a centralized device. Based on the centralized device, the data are shared to other connected nodes. So that device we call it as a concentrator or a hub. Mainly the term hub is used. So the data from various nodes on star network passes through the hub, and that hub will transfer to the requested node. The star topology is widely used in areas where control of the network is concentrated. Concentrated here is meant centralized. Next one is the advantages of topology, star topology. So first thing is it is easy to install and wire, because all the devices are connected to a central device. So we need to focus on the central device. From the central device only the connectivity starts. So it is very easy to install and wire, and it is easy to detect and rectify the if any error occurs. If a node is disconnected or removed from the network, it does not affect the working of the other node, because each and every node, each and every device are connected independently. Each and every device that are connected to the hub, that is centralized device, independently, because each and every device are not connected to each other. All the devices are connected to the hub only. So in case if any device is got fault, so it doesn't affect the other devices. The protocols, the set of rules, the predefined instructions are very simple. So as any given connection only involves the hub and the connection node. So the protocols is very easy to define. Here you can able to see the image of the star topology. So the nodes and the systems are connected to a centralized device that we called as a hub. And next one is the disadvantages of the star topology. So as each node directly connects to the hub, often long lengths of the cables are required. Some nodes may be at a different location or some longer distance. It needs a longer length of the cable because it is directly connected to the hub, and this increases the cost of the cables and their maintenance and installation. So all these are the disadvantages. If the central hub fails, the entire network fails. So if any problem occurs in the centralized device itself, the entire network will get failed. So one computer with a virus can infect all computers on the network. So we told that if any fault occurs in any nodes, it doesn't affect. Whereas if any virus affect the computer in the node, it affects all the other nodes on the network, because the data are transferring, and even the virus will transfer through the network to the other devices. So the number of nodes that can be connected to the hub is limited by the availability of the connection points. So for example, in a hub, there may be some minimum connection point. So we need to install, if we need more number of nodes, means we need to install a separate hub for that. So that the number of nodes that can be connected to the single hub is limited by the availability of the connection point based on the manufacturing of the hub. So these are all the disadvantages of the star topology. And next one is a bus or linear topology. So linear means it is connected in a single line. So in bus topology, the various nodes are connected, the various computers, the devices are connected through a single length of transmission cable, transmission wire, that we called as a bus. So in this type of topology, the server, the common device, the common computer where it has all the data and softwares, that server is connected at the one end, and it communicates with the several nodes attached among the bus. So the server will be at the one end. So all the devices will be connected in a single line. So based on the request, the server will send the response to the requested nodes, and the data is transmitted in small blocks. That small block of data, the combination of data, we call it as a packet. So these are all the terms used in the network. So the transmission from any node travels the length of the cable in both the direction. So it is a bidirection and can be received by all other nodes. So once the data is transferred from one end to another end, all the nodes will receive the data. So the bus is terminated at both the ends with a device called terminator. So the terminator will be connected at both the ends. So that common set of nodes connectivity will comprises a bus topology. So here you can able to see the image. So all the devices and the nodes are connected in a single line. And next one is the advantages and disadvantages of a bus topology. So first we see the advantages of the bus topology. So the wiring layout of the bus topology is very simple because it is a single line. So a short cable length is sufficient to connect the nodes to the backbone of the cable. To each and every nodes are easily connected with a single line. So it needs a very short cable length, and the bus network is easy to extend. Even we can extend the cable, and also we can add many nodes. Additional nodes can be connected to an existing bus network at any point, because all the nodes are connected in a single line. So anywhere we can connect the nodes. And in case if any extensive additions have to be carried out at after the terminator, so we need to extend the terminator, means a signal amplifier called repeater is added to the bus. So we can add a repeater, and by adding the repeater we can extend the uh, after the terminator line. And next one is the disadvantages of bus topology. The entire network is dependent on the main or the bus cable. So all the nodes are dependent on the single cable. If there is a break in the main cable, means the entire network gets failed. So since the control of the network is not centralized, so fault detection is not easy, because if any device gets failed, we can't able to identify the fault where it occurs, because all the devices are connected in a single cable. First we have to identify whether the cable gets failed, and then only we can able to monitor the nodes which are get affected. So to locate the fault, many points have to be checked. This topology works best when there are few computers. So few computers are connected, means this topology works for the best. A large number of computers could lead to a performance problem, because all the devices will request the data from the server. So the data weightage, if gets more, the cable can't able to transfer it at very fast rate. So this is the main disadvantage of the bus topology. Next one is a ring or circular topology. So from the name itself, we can able to guess how the connectivity will be. So the connectivity will be in a circular form. So in ring topology, each node is connected to two neighboring nodes. So a device will be connected to the two device. So that is the meaning of the two neighboring nodes. Data is accepted from one of the neighboring nodes and is transmitted to the other. So from one device, the data is transferred to the middle device, and the middle device will transfer the same data to the next device. So like passing on the relay. So thus data travels in one direction only. It is a unidirection. Uni means one. From one node to another node around a ring form. So after passing through each node, it returns to the sending node, which removes it. So you can able to see the image how the devices are connected in a ring form. Next one is the advantages of ring topology. So the length of the cable used in the ring topology is shorter as compared to the both star and bus, and this increases the reliability of the network because the neighbor device will transfer to the middle device and the middle device will send the same data to the next device. So the reliability is more when compared to the star and bus topology. The ring topology works very well with the optical fibers, resulting in very high speed transmission of data because the optical cable only can able to transmit more data at a faster rate. So in previous topologies we found the bulk of data, the more data can't able to be transmitted at a faster rate. When more data gets transmitted means the performance will get reduced. So to avoid that, the optical fibers is used in the ring topology, resulting in which very high speed transmission of data. And next one is the disadvantages of ring topology. The transmission of data goes through every connected node on the ring before returning to the sender. So it takes more time. So if any one node fails in between to passing the data, the entire network fails. So and no data traffic can flow until the defective node has been removed. Until the fault is rectified, the data will not be removed and the data will not be passed to the destination. So in addition, any cable failure between two nodes can cause the entire network to fail. So that is the main disadvantages in the ring topology. So and it is also very difficult to diagnose the faults in this topology. So because series of adjacent nodes, series of the nodes are connected between two devices, and in case if any one device gets failed, the entire network will get failed. And also it is not possible to power off or shut down the specific node. If any one node gets shut down means gets failure of power off means the entire network will get shut down. And the next topology is tree topology. So the shape of the network is that of a inverted tree. So you can able to see the image how the topology are connected. The topologies are connected in a tree form. So this topology is a combination of bus and star topology. So both bus topology and star topology combines to form a tree topology. So the backbone of this topology is the bus cable. The cable is a centralized cable. A single cable is used in the tree topology. The nodes are connected to the bus cable through the hubs. So both star and the bus topology combines to form the tree topology. The star topology, two or more star topologies are connected in a bus topology. That is the exact meaning of the tree topology. The server is directly connected to the bus. Since tree topology is a combination of, we told that bus and star. So it is also a hybrid topology. It's a combination of bus and star topology. So we call it as a hybrid topology. The transmission of data takes place in the same way as in the bus topology. There is no change in the transmission of data when compared to the bus and this tree topology. So you can able to see the image of the tree topology. It looks exactly similar to the tree. In the center line you can able to see the bus topology, the cable, centralized cable, and two or more star topologies are connected to the centralized cable. And next one is the advantages of tree topology. So it is easy to expand the network as the new users, as many users are added. It is easy to expand the network and it can be added by adding a new hub. And also since it is a commonly deployed topology, it is supported by large number of hardwares and the softwares. So these are the two main advantages of the tree topology. Next one is the disadvantages of tree topology. the segment is limited by the limitations of star topology. So in star topology only we have some limitation, we can able to connect only limited device, whereas in tree topology we can connect as many as star topologies. So we need, if any new users or many users to be added means, we can create 2 or more star topologies. So example, the type of cabling used limits the length of each segment. The based on the cable capacity, the star topology limits the number of users in the network. So if the backbone of the line breaks, that is the bus topology breaks, means the entire segment will get failed. So that is the main disadvantage of the tree topology. If the bus topology gets, the center line gets failed, means the entire network will get failed. This topology is more difficult to configure, to connect, and also wiring is more difficult other than the topology, because it has both bus and the star topology, because we use so many hubs, and in star topology the connectivity is more complex. So we are using 2 or more star topologies, so the complexity gets increased. And the last one is the mesh topology. So in this topology, the devices are connected with a many redundant interconnection between nodes. The nodes have many connections. So in a fully connected mesh topology, every node has a connection to every other node in the network. So each and every node will have connectivity to the other nodes that are connected in the networks. So it means a single node can have more than 2 or more than connectivity to the other nodes. Because of multiple links, if one route gets blocked, the other routes can be used for data communication. So we told that a single node will have 2 or more connectivity. In case if single node gets failed, means the other node, other connectivity can be used for data communication. So you can able to see the image how the nodes are connected. So each and every node will have connectivity to the other nodes that are in the network. And next one is the advantages of the mesh topology. So this topology has multiple links. So if any one link is failed, means the other link, other route can be used for data communication. So the design of the topology shows it leads to minimal or no traffic congestion. So here traffic congestion means the traffic problem. The term traffic means if two or more nodes sending the request simultaneously, or requesting for a particular data, for a particular bulk of data, huge amount of data, means there won't be any slow performance. So that is the term traffic means here. The traffic problem is eliminated because each connection has its own data load. So there are so many cables used, so each cable has its own data load. So the data load can be easily shared and avoid the slow performance. And also it ensures high level of data privacy or security, because every message, the every data travels along a dedicated link, so it has some unique link. So each and every node has a unique link. The last one is troubleshooting of this topology is easy as compared to other networks, so its performance is not affected. Because of the easy troubleshooting, the performance will not get affected even with the heavy load of data transmission. So here the heavy load of data we call it as a traffic. And the disadvantage of mesh topology is it becomes very expensive, because the large requirement of cabling is needed. So and also it is very difficult to install, because all the nodes are get connected to each other in the network. So the installation procedure is very difficult. And the next topic is protocol. So protocol is a set of rules or instruction, we have already told. So it refers to the set of rules that computers follow on the network to communicate with each other. So for each and every communication there will be a set of rules how the computers to be communicated. The protocol rules apply to the even to the cabling. So physical topologies, we have told that physical topologies, how the cable should be, how what are all the cabling should be used. So all the rules can be applied, and the access method used by the network elements, both even it may be a hardware or software. So all these things in the network are predefined, will have some set of rules. So Ethernet and the token ring network are examples of the popular protocols. So Ethernet is also a network connectivity, and also the ring network is also a example for the popular protocols. So we see what is a Ethernet. So Ethernet protocol is most widely used for setting a local area network, specifically for star and bus topologies. So Ethernet is mainly used for in the star or bus topologies. So in this, the computer first ensures that the network cable is clear. So there is not any problem with the network cable, and has no data in the network cable. So first that is ensured. If any devices attached to the network, such as it may be a server or a printer or a workstation, is in use and sending data on the cable, the computer will wait and try again when the line is clear. So until the line is clear, the data will not transmitted between the lines. That is the main advantage of the Ethernet cable. And next one is a token ring. So the token ring protocol makes the network in the form of ring. From the name itself, it is identified that it forms a ring structure. So comprising of a controlling computers and other computers. So it connects all the computers in a ring form. So this protocol has become obsolete because it has so many disadvantages, as we have seen in the ring topology, so that it is no longer in use today. So it needs the connected devices, all the devices, the data must travel all the devices that are connected in the network. So that takes more time for communication. So that's why this token ring protocol has become obsolete and there is no longer in use today. And the next one is architecture. So this specifies the physical components, their organization, the how they are organized, and the configuration, how the physical components are configured, and the data formats used in the process of networking. So all these are specified in the architecture. So the classification of network architecture is based on the distribution of the task. So how the data are distributed, based on the distribution the network architecture is classified. So and also it classified based on the workload, the we told that traffic. So the traffic between the different elements of the network, the different nodes of the network, and based on that we have classified into two types, that is peer to peer architecture. So here peer to peer means nodes to node, the node or a system we call it as a peer. So the peer to peer architecture. So in a peer to peer networking configuration, the tasks are distributed among the peers. Here wherever the term peers means, it refers to the nodes who are all equally privileged. So each and every node will have some access permission or some privileges. So based on that privilege, the distribution occurs. So this system does not have any central infrastructure on a or a server. The computers that are connected with each other in a work group to share files, printers, and even the internet access. So the computers are connected in a group, they can able to share the files, printers, and also even the internet access. So this is about the even the nodes to node are connected, that is the peer to peer architecture. So the architecture is fully based on the nodes to node. And next one is a client server architecture. In a client server architecture, the tasks are distributed between the server and the clients. So here we already told that server is a common system where all the data are stored, where all the softwares are stored, and the clients are nothing but the users, the other nodes, which send the request to the server. So the clients sends a request to the server for any specific data or software permission. So the server, based on the request, it sends a response to the client. So a client does not share any of its resource to the other clients. It just sends a request to the server for content or a service. The servers in return provides the resource or the service on the request from the clients. So only the communication occurs between the client and the server. So the communication is initiated by the client while the server waits for the request, incoming request. A client can log or can record the request, send what are all the requests that are sent will be logged, and once logged to the server, the clients can access the internet or the data, whatever request. Based on the request, the client can access the internet data or the service. So this is about the client server architecture. So with this, the chapter 1 gets completed. So in this video, we have learnt about the computer network, what is a computer networking, and the advantages of the computer networking, and the basic components, both the hardware and software, and the various types of network based on the geographical spread, the local area network and the wide area network, and the various characteristics of a network, the topology, protocol, and architecture, and how the topology gets classified. Uh, Star topology, bus topology, ring topology, tree topology, and mesh topology, and the protocols, the Ethernet protocol and the token ring protocol. And the last we have seen about the architecture. So the peer-to-peer architecture and the client server architecture. Thank you, students.